In this lesson, we're going to take a look at transformations of absolute value functions. So our goal is to be able to graph an absolute value or a V-shaped graph without using a table. Our parent function you see here is going to be f of x equals just the absolute value of x. And our transformations, we're going to want to identify the value that's being multiplied by the absolute value, the number that's being added or subtracted inside our absolute value, which will be our h, and that will give us the first number in our vertex. And then the value that's being added outside, that will give us our last number. And that multiplier out front, notice that is what our slope is going to be. So each absolute value graph is going to be a perfect V. It's either going to be upright if our A value is positive, or it's going to open downward if our A value is negative. So if we take a look at this parent function, I want to rewrite that function in this form. So this is going to be the function f of x, where the multiplier in front is going to be 1 times the absolute value of x minus, there's nothing in there, so 0, and then plus nothing. This tells me that my vertex is going to be the value inside here, so 0, and then the value outside, 0, and that my slope is going to be 1. So I'm going to go to this location, which is the origin. I'm going to put my first point there. And from there, I'm going to go ahead and I'm going to rise up 1 and over 1. So a slope of 1 is the same as 1 over 1. So I'm going to take each of these points, and from this center, I'm going to go up 1 and to the right 1. And then again, from there, I'm going to go up 1 and to the right 1. And I can continue that as many times as I want. Then I'm going to mirror that. I'm going to go back to my vertex. Instead of up 1 and to the right, I'm going to go up 1 and to the left. Then similarly, I'm going to go up 1 and to the left from there. So if I connect these using a straight line, I'm going to get a V-shaped graph here. Okay. My V graph opens upward because my A value here was positive. My vertex is at 0, 0. My slope is up 1 and over 1. If I want to take a look at this, and I want to take a look at my domain and range, my domain here and my domain of any and all these absolute value functions is always going to be still negative infinity to infinity. Okay, and this time, for this function here, the absolute value, my range in this particular case, my range goes from this y value of 0, and including that value, and then up to infinity. Let's take a look at our next example here, or our first transformation example. We're going to use the transformations of this parent function to come up with this graph. So if I take a look, the key information I want to identify is my vertex, which is going to be located at the opposite of this value, -4 or -4, and then comma -6. And then my slope is going to be 3 or 3 over 1. So I'm going to take my points here and I'm going to plot them. I'm going to start at -4, -6. So to the left 4 and then down 6. And then from there I want to count up 3 and to the right 1. So I'm going to go from this point up 3 to the right 1. And I could do that a second time. Up 3 and to the right 1. And then I'm going to go back to my vertex and I'm going to go up 3 into the left 1. And again from that point up 3 into the left 1. So I'm going to connect these with a V-shaped graph. And my V-shaped graph here is going to be stretched and a lot more narrow. Okay, it's more narrow because I have a slope of 3 this time instead of a slope of 1. So I'm increasing at a quicker rate. So my V is steeper. It's still opening up because my A value, or this value here, was positive, so I'm still opening up. And if I take a look again, my domain is still going to be the same, negative infinity to infinity, but this time my range for this blue function is going to be starting from -6 and including -6 and then going up to infinity. So lastly, let's take a look at our green function here, our third example or our second example of transforming from our parent function. Our vertex is located at 2, 3, and then our slope this time is -1/3. So this time I'm going to start at 2, 3. So to the right 2 and up 3. And from there, I want to count down 1 this time and to the right 3. So from this green point, down 1 to the right 3. From there, I'd go again, down 1 to the right 3. Okay, I'm going to do that again, but this time I'm going to go from the vertex down 1 and to the left 3. And then from there, I'm going to go down 1 to the left 3 again. Okay, so if I connect these, you can see that we have a V-shaped graph. My V-shaped graph this time is opening down because my slope is negative. Okay, it's wider, much wider, because this time I'm going only down by a little and over by a lot more. And my vertex is again +2, 3. And if I go to identify my range here, this time my range has a maximum. I'm starting up at the value of 3, but I'm going down. So to write that, I'm going to say that we're going to go from negative infinity up to and including 3. So in summary, I still have very similar transformation rules as I did for a quadratic function. This time I want the opposite of the value that's inside the absolute value bars, comma, the number outside for my vertex. And I just want that multiplier up front to be my slope. The domain will always be from negative infinity to infinity, but my range will vary. Each time I go to graph, I should always have a V shape, and I know it'll be opening up if my A value is positive. It'll be opening down if my A value is negative.